Welcome to Vibratech Trainers and Consultant Private Limited. We are going to see an interesting case study on centrifuge balancing. This is applicable for all types of industrial centrifuge. Case study prepared by Vijayakrishnan Venugopal, Director of Vibratech Trainers and Consultants Private Limited, Chennai. He is a chartered engineer with more than 35 years of experience. He is an international vibration consultant and ISO certified vibration analyst Cat 3 certificate holder. Also, he is certified maintenance and reliability professional from SMRP. Centrifuge we are going to see is directly coupled with motor of capacity 160 kilowatts and running at 1200 RPM. The centrifuge is mounted on steel frame at above ground level with anti-vibration mountings. Vibration measurements are taken in all three directions: horizontal, vertical, axial, in each locations. Measurement locations are motor non-drive end bearing, motor drive end bearing, centrifuge bearing. Vibration data are collected in terms of displacement in microns peak to peak and velocity in millimeters per second peak. Now onto the vibration limits. As per ISO standard, and with our previous experience, when the velocity falls below 10.0 mm per second peak, it's considered as good. When the velocity falls between 10.0 to 25.0 mm per second peak, it is considered as fair. And when the velocity falls above 25.0 mm per second peak, it is considered to be rough. The vibration values are maximum at motor drive end vertical, velocity up to 4.1 mm per second peak with displacement of 59 microns peak to peak, and at centrifuge drive end vertical, velocity up to 12.3 mm per second peak with displacement of 190 microns peak to peak, and the equipment falls under fair category. On going through the spectrum and frequencies at motor driven end, dominant peak frequencies is in 1 times the running RPM. And spectrums at centrifuge drive end side shows the dominant peak frequencies is in 1 times of running RPM. Both the spectrums indicates unbalance in centrifuge basket. The centrifuge was analyzed at full speed of 1200 RPM. Dominance of 1 times rotational speed component was indicated at centrifuge bearings with 82° phase shift between horizontal to vertical direction at centrifuge bearing locations. Analysis indicated unbalance of the centrifuge basket. After that, the initial analysis, the centrifuge basket was taken up for in situ dynamic balancing. Correction weight of 1700 grams added to reduce the vibration levels from 190 microns and 12.3 mm per second to 45 microns and 2.9 mm per second. After the balancing, vibration data are collected. The vibration values are maximum at motor drive end vertical, velocity up to 4.7 mm per second peak with displacement of 55 microns peak to peak, and at centrifuge drive end axial, velocity up to 3.4 mm per second peak with displacement of 70 microns peak to peak, and the equipment improved to good category. The comparison spectrums after balancing. The spectrums shows the first peak frequency velocity value is reduced from 12.23 mm per second peak to 2.6 mm per second peak. After the in situ dynamic balancing, the health condition of the centrifuge is improved from fair to good category. Vibratech cater among all major industrial sectors. We conduct vibration analysis level 1 and 2 training programs online and also in plant. ISO certified vibration analyst category 1, category 2, category 3 training and examination. Services we provide are vibration analysis, in situ dynamic balancing, laser alignment, motor current signature analysis, thermography, building or ground vibration measurements. We also market and provide service for machinery vibration analyzers and meters, and low frequency building vibration analyzers.